or arrived derivatives of ammonia means that these hydrogen atoms can be replaced by aryl or alkyl groups. Hence, you will obtain amines. Hybridized orbitals of nitrogen in these three bonds which is formed, it is forming or overlapping with the orbital of hydrogen. One hydrogen atom is replaced by a methyl group. So it was NH3 before, one H is replaced by CH3. So you will of course get CH3 NH2, right? So this is called as methyl amine. Hello everyone, this is Ambali Unnikrishnan from the Department of Chemistry. So today I am back with a new chapter, that is chapter 9 of your syllabus, amines. Okay, so in today's session we are going to see what is exactly amines, right? And then we'll be discussing the structure of amines, classification of amines and nomenclature of amines. So this is also a chapter included in organic chemistry. So as we have studied the other organic chemistry chapter, the same way we are going to discuss here as well. We'll begin with the structure and nomenclature. Later on, we'll move on to the physical properties and chemical properties of amines, right? So first, let us see what is amines. Amines are alkyl or aryl derivatives of ammonia. So the main person here is ammonia. So the alkyl or aryl derivatives of ammonia is called as amines. So what is ammonia? NH3 is ammonia, right? So you can see in NH3 there are 3 hydrogen atoms which is present, and there is a lone pair of electron in nitrogen atom also. So this is ammonia. So you have already studied the structure of ammonia in class 11 itself, right? Okay. So this is the structure of ammonia. So here you can see 1, 2, 3 hydrogen atoms. Okay. So alkyl or aryl derivatives of ammonia means that these hydrogen atoms can be replaced by aryl or alkyl groups. Hence you will obtain amines. Okay. Those are derivatives of ammonia wherein hydrogen atom will be replaced by any other alkyl or aryl group. Clear? In nature, they can occur among proteins, vitamins, alkaloids and hormones. And amines are the starting material for the synthesis of many substances like polymers, dyes and drugs. So these are few uses of amines. So let us understand further about amines. Amines are alkyl or aryl derivatives of ammonia and are obtained by the replacement of one or more hydrogen atoms of ammonia by alkyl or aryl group, as I have discussed before itself. So you can see CH3NH2, which is called as methyl amine. So how is this amine obtained? You have ammonia in which one hydrogen atom is replaced by a methyl group. So it was NH3 before, one H is replaced by CH3. So you will of course get CH3NH2, right? So this is called as methyl amine. Clear? Methyl amine. So now in this case you can see one more hydrogen atom from ammonia. One more hydrogen atom is being replaced by another alkyl group. Which one? Methyl group. So you have one CH3 here, another CH3 here. And it was NH3 wherein 2 hydrogen atom is being replaced by these 2 methyl groups. So you have dimethyl amine. 2 methyl groups are there. So it will be NH, right? Now, there is one more hydrogen atom that can be replaced. This hydrogen atom can also be replaced by another alkyl or aryl group. So, you can see here, one more methyl group is being replaced. So, you have CH3, 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 N. So, this is trimethyl amine. So, you can have methyl amine, dimethyl amine or trimethyl amine by replacing one by one hydrogen atoms. Clear? So, now let us understand the structure of amines. In nitrogen atom of amines carries an unshared pair of electrons. So, you can see the structure of ammonia, NH3. Right, and it is having a lone pair of electron because nitrogen is having the valence electrons 5. So 1, 2, 3 already forming bond with hydrogen, 2 more left behind, that will be present as lone pair. Clear? Now in amines, nitrogen is sp3 hybridized. Now why is it sp3 hybridized? You can see there are 1, 2, 3 bond pairs. There are 3 bond pairs and you have 1 lone pair, right? So totally that will give you 4 electron pairs, right? 3 bond pairs in one lone pair, totally it will be 4 electron pairs. So if 4 electron pairs are present, what is the geometry? It will be tetrahedral. That is why it is sp3 hybridized. sp3 hybridized. You can see the nitrogen is further attached to 3 other hydrogen atoms. Clear? Now aliphatic amines have a pyramidal shape that is approximately tetrahedral when we assume the electron pair on nitrogen, a group. Okay. So if you are considering this electron pair, that is a lone pair of electron also as a group, then totally 4 electron pairs will be there. In that case, it is supposed to be tetrahedral, right? So that is a tetrahedral shape. Each of the 3 sp3 hybridized orbitals of nitrogen overlap with orbitals of hydrogen or carbon depending upon the composition of amines. The 4th orbital of nitrogen in all amines contain an unshared pair of electrons. So you can see the hybridized orbitals of nitrogen in these 3 bonds which is formed, it is forming or overlapping with the orbital of hydrogen. But in all cases of amine, even if these hydrogen atoms are being replaced, this unpaired electron, that is lone pair of electrons, will be present there. Due to the presence of this unshared pair of electrons, that lone pair of electron, lone pair bond pair interactions will be there. We have studied VSEPR theory, all right. Yes, the angle between C and E, that means the carbon, nitrogen, and the angle C and E, wherein E is the carbon or hydrogen, is less than 109.5 degree. For instance, it is 108 degree in case of trimethyl amine. So what is happening here is, as discussed in, this is ammonia structure, you can see here, this is the lone pair of electron which is present. According to VSEPR theory, we have studied that there will be lone pair, lone pair, lone pair, bond pair, and bond pair repulsion. So actually, it is supposed to be tetrahedral structure because of 4 electron pairs. But because of the repulsion between this lone pair and this bond pair and bond pair, what is happening? The angle is already reduced to 107 degree from 109 degree. Right? And if you are considering trimethylamine also, this is also supposed to have tetrahedral structure. But because of the lone pair, bond pair and bond pair repulsions, the angle is reducing to 108 degree. Clear? Right. Now, let's move on to the classification of amines. Amines can be classified into primary, secondary or tertiary amines depending on the number of hydrogen atoms of ammonia that have been replaced by alkyl or aryl group. So, ammonia, NH3, right? If one hydrogen is replaced by any alkyl or aryl group, what you will get? RNH2 you will get. So this is going to be a primary amine. Then one more hydrogen if I am replacing, it is going to be R2NH, right? One more hydrogen is replaced and one more alkyl group is added. So this is called as secondary. Now one more alkyl group or aryl group I am going to add by replacing another hydrogen atom. You are going to get R3N. That is called as the tertiary amine. Simple. So let's see. NH3 is there, which is ammonia. So one hydrogen atom is going to be replaced by an alkyl or aryl group. So that is called as your primary amine. Now we are going to replace one more hydrogen atom. That is, this hydrogen atom is also going to be replaced. So you have 2 alkyl group, that is R2NH, which is secondary amine. Now the third hydrogen atom also we are going to replace. Now you will have R3 and 1N. That's it, right? So you have R3N, which is called as the tertiary amine. So this is how you obtain primary, secondary and tertiary amine. Clear? It is just based on the number of hydrogen atoms being replaced by alkyl or aryl group. Now, what are aliphatic amine? An amine in which nitrogen is bonded to an alkyl group. Okay, so the hydrogen can be replaced by an alkyl or aryl group, right? So if it is replaced by an alkyl group, it is called as aliphatic amine. Okay, so you can see methylamine, which is a primary amine. Why it is primary? Only one alkyl group is present here, right? Now you have dimethylamine, which is also aliphatic, but you have 2 methyl groups. So this is R2NH. So this is dimethylamine and it is secondary amine, right? Now you have 1, 2, 3 methyl groups. So this is a trimethylamine and of course it is tertiary amine. Clear? Right. Now moving on to aromatic amine. Now we know that aliphatic amine means the hydrogen will be replaced by a alkyl group. Aromatic, of course, it will be replaced by an aryl group, right? An amine in which nitrogen is bonded to one or more aryl groups. Okay. So here also you can see ammonia, hydrogen is being replaced by an aryl group. What it is? It's a benzyl group. So this is called as aniline. Aniline. On benzene, you have an NH2 that is called as aniline. in IUPAC as well as common system that we will discuss later. So this is called as primary aromatic amine. Why it is primary aromatic amine? Only one aryl group is present. Now you have an aryl group and you have a methyl group. Two hydrogen atoms are being replaced. So this is a secondary amine, right? So this is a secondary aromatic amine. It is called as N-methyl aniline. Why N-methyl? On the nitrogen atom, the methyl group is present. That is why it is called as N-methyl aniline. Clear? Now you have the third structure in which all the three hydrogen atoms are being replaced. You have two methyl groups and one benzyl group also. So this is NN dimethyl. Both the methyl groups are present on the nitrogen. That is why NN dimethyl aniline. Okay, NN dimethyl aniline, which is tertiary aromatic amine. Why it is called aniline? Because it is a derivative of aniline, right? Aniline is NH2, wherein the two hydrogen atoms are replaced by two methyl groups. That is why it is called as NN dimethyl aniline. Clear? Now there is one or more class of amines besides these three types in which nitrogen atom is quaternary. So we have discussed primary, secondary and tertiary structure. Now there is quaternary also. The derivatives of ammonium salt in which all four hydrogen atoms are replaced by alkyl or aryl groups are called quaternary ammonium salts. Okay. So if three hydrogen atoms are being replaced, you get what? You get primary, secondary or tertiary amines. Now the last one also can be obtained. That is, you can see NH4 plus and X minus, wherein all this hydrogen atoms. So this is not ammonia, this is a salt of ammonium. This is ammonium, right? Ammonium salt it is. So here you can see four hydrogen atoms. All of these four hydrogen atoms can be replaced by alkyl or aryl group. So you'll get NR4, right? So that is called as a quaternary structure. Okay, so I hope that is clear. Now moving on to the nomenclature. So according to common system, an aliphatic amine is named alkyl amine. Alkyl amine. So if hydrogen atom is replaced by a methyl group, it will be called as methyl amine according to common system, right? As one word, in secondary and tertiary amines, when two or more groups are the same, the prefix di or tri is used before. So we already know that if more than one same group is present, we'll write it as dimethyl or trimethyl. Clear? Now moving on to IUPAC system. The aliphatic names are named as alkyl amines. These names are obtained by replacing the terminal E of the parent alkene by suffix amine. So E we are going to replace by amine. Okay. The suffix here is amine. Okay, the substituents which are attached to the nitrogen atom instead of the carbon of the chain are designated by the capital N. So usually when we name the organic compounds, if other substituents are present, what do? We'll mention it using the numbers. That is, if any substituent, for example, chloro group is present on the second carbon atom, we mention it as 2-chloro. But here we are dealing with ammonia, so it's not carbon, it is nitrogen atom. So instead of numbering it as 1, 2, 3, we are going to write N here. Okay, so that we'll discuss now. Then the names of aromatic amine, the simplest aromatic amine is C6H5NH2. What is C6H5NH2? That is benzene. One hydrogen atom is replaced by amine, NH2. Right. In common system, it is called as aniline. Its simple derivatives are named using the prefix ortho, meta or para according to common system, or numbers to locate the substituents. While naming aryl amines, according to IUPAC system, suffix E is replaced by amine. So in alkyl or aryl amines, when we are writing the IUPAC name, the E will be substituted by amine. So let's discuss few examples and understand this. So the first one is CH3NH2. So this is a primary amine. So according to common name, how do we write it? It is just alkyl amine. So which is the alkyl group here? Methyl. So you write methyl amine. And IUPAC name, it is based on the hydrocarbon. Which is the hydrocarbon? It is methane, right? CH4, methane. So instead of E, you are going to substitute it by amine. The suffix will be amine. So you will get methanamine. Methanamine. Clear? So from methane, that E is replaced by amine. Clear? Now you have CH3, CH, NH2, CH3. So this is isopropyl amine. Okay, that is the second carbon atom is having the NH2 group. Okay, so this is isopropyl amine. Now what will be the IUPAC name? It is 2-propanamine. That means on the second carbon atom you are having the amine group. So this is 2-propanamine. Why propanamine? 1, 2, 3. 3 carbon atoms. Clear? Now moving on to CH3, NCH3, CH3. So this is a tertiary amine, right? So here you have 3 hydrogen atoms replaced by CH3 groups. That is why it is a tertiary amine. So it is called as trimethylamine, right? There are 3 methyl groups, so it is called as trimethylamine. Now IUPAC name will be N-N dimethyl methanamine. Okay. So this much part is your methanamine, CH3NH2, from which 2 hydrogen atoms are replaced by CH3 and CH3. So this is N, N dimethyl. As discussed before, it's not carbon atom, so we will not mention the number. It will be the nitrogen atom that we are going to write. So that is why it is N, N, dimethyl and methanamine. Clear? You have CH3, CH2, NH2. Okay. So this is ethylamine. Simple. Ethyl, CH3, CH2 is what? The alkyl group here is ethyl. Now it is called as ethanamine. IUPAC name is ethanamine. Now you have CH3, CH2, CH2, NH2, which is propylamine. So you have 3 carbon atoms here. So it is propylamine and it is propan-1-amine in case of IUPAC name. Now you have the simplest aromatic or aryl amine, which is the benzene ring with NH2 group. So this is called as aniline, and IUPAC it is called as benzenamine, or else aniline can be also used as IUPAC name. Clear? Now let's discuss few aromatic amines or aryl amines. So this much part you can see, this is aniline, right? Already aniline is here. So you can write it as a derivative of aniline, or else another name is benzenamine, right? Either way you can use. Okay. So the common name is orthotoluidine. Now why it is toluidine? So on benzene you are having the methyl group. So that is called as toluene. We have already discussed this, right? On benzene you have methyl group, that is called as toluene. And on the ortho position, this is the ortho position, right? So in the ortho position you have the amine. So that is why it is called as orthotoluidine, right? Or else in IUPAC name you can write it as 2-methyl benzenamine. So this much part is benzenamine, and on the second carbon atom, this is the first carbon atom, second carbon atom you have the methyl group. That is why 2-methyl benzenamine. Now moving on to this on the first carbon atom you have the amine. Now 1, 2, 3, 4. On the fourth carbon atom you have the bromine. So IUPAC name will be 4-bromoaniline or 4-bromobenzenamine, right? 4-bromobenzenamine or 4-bromoaniline. Common name will be para-bromoaniline. Now why para? These 2 are ortho positions, these 2 are meta position, and this is the para position. So it is para-bromoaniline. In common system you don't number 1, 2, 3, 4. It is ortho, para or meta. In IUPAC name you are not supposed to use ortho, para or meta. Now here you can see the structure. You have a CH2 here and NCH2, CH3, and again you have a benzene ring here. So the name IUPAC name is N-benzyl N-ethyl benzenamine. Now how it is N-benzyl N-ethyl benzenamine? Now as you can see here, on the nitrogen atom which is present, you have an ethyl group, that is your N-ethyl, and you have a benzyl group also, that is N-benzyl. Now on this nitrogen you are having ethyl as well as benzyl attached. Now why I have written N-benzyl first and then N-ethyl? That is because according to the alphabetical order, B will come first before than E. So that is why whichever comes first in the alphabetical order, that you have to write first. So N-benzyl N-ethyl is done. Now this much part is what? It is benzenamine. Now what is left behind this much part? That is benzenamine. You have benzene, CH2, NH2, that is benzenamine. That is why it is N-benzyl N-ethyl benzenamine. So this is the IUPAC and common system nomenclature of amines. So in the next session, we are going to study about the preparation of amines, moving on with the physical and chemical properties. So I hope the concepts that I've covered in the session is clear for you. So that's all for today. Thank you.